This is part 3 of a series concerning questions about thermodynamics. So, question number 20 says that 2 moles of helium, the number of moles is given as 2 moles. The gas is helium. Helium is monoatomic. 2 moles of gas, the gas is helium, which are simply found at an initial temperature of 27 degrees Celsius, that's about 300 Kelvin. Occupy a volume, we have an initial volume of 20 liters, that is 20 times 10 to the minus 3 meter cubes. Now the helium is first expanded at constant pressure, that is number 1. We have the first system, which is simply an isobaric. During an isobaric process, the helium is expanded until the volume has doubled. So V1 goes to 2 V1. This implies the volume goes from 20 liters to 40 liters during our isobaric expansion, and then until it has doubled, and then adiabatically, and then we have an adiabatic process, during which the adiabatic process it is expanded until the temperature returns to its original value. So until the temperature at this position, we have T1 going to T2, and then we have from T2 goes back to T1. So question number A says to draw the PV diagram. Now to draw the PV graph, we can begin by laying out our foundations. This is going to be our pressure and our volume. So suppose that this is going to be its initial position. So here it's going to be found at a volume of 20 liters and at some pressure which we do not know for now. Now it is expanded isobarically, that's at constant pressure, until the volume has reached twice, that is 40 liters. And then during an adiabatic process, that is going to have a hyperbolic isothermal graph. It is all again expanded until it reaches some temperature which is equal. This temperature, that's suppose this is A, B, and C. So it goes from A to B and then from B to C. Now the first bit of adiabatic position is that መጨረሻ ላይ እዚህ ጋር ያለው ቴምፕሬቸራችን ዳስ ቴምፕሬቸር አት ሲ is the same as the temperature at A ብሎ ሰጥቶናል። አንተ ቴምፕሬቸራቸው ኢኳል እስኪሆን ድረስ ነው። this is PV ግራፉ ነው የሚመስለው። አሁን የመጀመሪያው ጥያቄ ምንድነው? what is going to be the total heat ነው። that is Q total ምንድነው የሚሆነው ነው ጥያቄው ስናይ። now Q total መፈለግ እንችላለን። እና እንዴት ነው Q total የምንፈልገው? number 1 ፕሮሰሱ ስናይ ከቢ ወደ ሲ አዲያባቲክ ነው ብለናል። so Q እዚህ ጋር 0 ነው። so the only value Q ቢኖረን Q ከኤ እስከ ቢ የሚሄድበት ፕሮሰስ ላይ ያለው ኪው ብቻ ነው የሚሆነው። ሶ ኪው ቶታል is the same as to ኪው ከኤ ወደ ቢ ያለው ብቻ ነው የሚሆነው። ናው ከኤ ወደ ቢ ስናይ the process from A to B takes place at constant volume, at constant pressure አይደለ? this is constant pressure, and thus QAB is also going to be equal with QP, constant pressure ካለው ጋር እኩል ነው። so አሁን ይሄን ተጠቅመን let us try to figure out እዛ ላይ ያለውን questions. So, this one figure ለማድረግ we have at A ያለበት position ላይ, that is እዚህ ጋር we have PAVA equals to nRTA, right? ስለዚህ our pressure at A, that's PA, is nRTA over VA. So we have our number of moles, which is 2 moles times our R of 8.314 joule የሚለውን, let me write it as Newton meters, joule per mole Kelvin, multiplied by Zagallo temperature, which is 300 Kelvin, divided for our volume Zagallo, which is 20 liters, that's 20 times 10 to the minus 3 meter cubes. So 1 mole by 1 mole, Kelvin by Kelvin, kaza 1 meter square, 1 meter by 1 meter square. So we current unit ziga, we current unit Newton per meter square ይሆናል, which is the Pascal. So here we have our value of pressure at A to be approximately 250 kilopascals. So እዚህ ጋር ያለው pressure, this one becomes 250 kilopascals ይመጣል። Now after we know that is 250 kilopascal መሆኑን ካወቅን በዚህ ህግ ተጠቅመን we can try to find እዚህ ጋር ያለውን temperature, right? እዚህ ጋር 300 Kelvin መሆኑን እናውቃለን። እዚህ ጋር 300 Kelvin መሆኑን እናውቃለን። it is already given. እዚህ 300 ኬልቪን አለ። ይሄ ደግሞ TC cost TA ብለን ስለጀመርን 300 ኬልቪን አለ። so what is the temperature at TB የሚለውን we can use it because we can use the combined gas law ተጠቅመን we can arrive at P1 V1 ከማለት PA VA over TA equals to PP VB over TB. So from here our TB is going to equal to at VB over VA multiplied by TA metal. So this is VB twice the that's 40 liters. This is 20 liters multiplied by 300 Kelvin. So this literally gives me 600 kelvins. So እዚህ ጋር ያለኝ so the temperature at this position is 600 Kelvin ነው ማለት ነው። Now I know this is 600 Kelvin. ይሄ ደግሞ 300 Kelvin መሆኑን አውቃለሁ። I have my volume እዚህ ጋር and so I can find እዚህ ጋር ያለውን volume. How? I know that the process from B to C is an adiabatic process አይደለ? ስለዚህ I can use my equation. የትኛውን equation? T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1 የሚለውን equation ተጠቅሜ እዛ ያለውን value derive ማድረግ ይችላል ማለት ነው። ስለዛ at that position ምን እንደሚሆነው I'm going to have my T1 original እዚህ ጋር ያለኝ temperature T1 that's 600 kelvins እዚህ ጋር ከነጋ ልጻፈው አሁን እዚህ ጋር TB ነው የሚሆነው that's TB VB to gamma minus 1 is TC VC to gamma minus 1. Now TB is 600 Kelvin multiplied by my volume there is 40 liters to gamma minus 1 equals to my value of TC zaga it's 300 Kelvin no times malako that's VC to gamma minus 1 ይመጣል. This is let's 300 ባካፍለው I'm going to have 2 times 40 liters into gamma minus 1 equals to VC into gamma minus 1. በሁለቱም side I can multiply both sides by 1 over gamma minus 1 by 1 over gamma minus 1 ሁለቱም side. So this is going to leave me with 2 into 1 over gamma minus 1 times 40 liters equals to VC አገኛለሁ. Now gamma for a monoatomic gas is equal to 5 over 3 ጋር እኩል ነው። ስለዛ 5 over 3 ከሆነ 1 over 5 over 3 minus 1 yields 1 over 2 over 3 ነው ማገኘው which is 3 over 2 ይሆናል right ስለዚህ እዚህ ጋር በከተው 2 raised to 2 over 3 2 raised to 3 over 2 multiplied by 40 liters is VC. So this implies that VC this one is 2 root 2 አይደለ because this one is the square root of 8 multiplied by 40 this is 2 root 2 times 40 liters. So that VC is going to equal to 113 liters ይመጣል ማለት ነው. So this is VC. So that where was the graph? So my VC this one becomes 113 liters ይመጣል. Now since I have እዛ ጋር ያለ 113 liters መሆኑን ካወቅኩኝ using this and also using the other ሁለተኛውን የአዲያባቲክ law that is P2 V2 to gamma equals to P3 V3 to gamma አሁን እዚህ ጋር ልቀይራችሁ ቁጥሮቹ P2 የሚለው PB VB to gamma equals to PC VC to gamma አለዋለሁ. So from here I can find the pressure at C. So my pressure at C is going to equal to the pressure at B into a VB over VC times gamma ይመጣል which is the same as to PB 250 kilopascals times my VB that's 40 liters over my VC 103 liters multiplied by 5 over 3 ይሄ በዚህ ጣፋና I will be left with 250 kilopascals times 0.353 5 over 3 which is around 44.3 kilopascals. So እዚህ ጋር ያለው my pressure here is 44.3 kilopascals ነው ማለት ነው. So this is my complete graph. ስለዛ complete graph እንጨርሻለሁ. Now after this the second question is what is the Q total? Now the Q total እንዳወራ ነው is equal to the summation of all the heat terms. ከዚህ ወደዚህ ያለው የአይሶባሪክ ከዚህ ወደዚህ ያለው የአዲያባቲክ አዲያባቲክ ላይ q equal to 0 ስለሆነ the q total is going to equal ከa ወደ b ለመሄድ የሚያስፈልገኝ ሂት ጋር እኩል ነው የሚሆነው። and that amount of heat ደግሞ equals to qp. that's the amount of heat በኮንስታንት ፕሬሸር ላይ ገባው because እዚህ ጋር ያለው ኮንስታንት ፕሬሸር። ስለዛ my q total equals to my qp which is ncp times change in t ይመጣል። ስለዛ my n it's 2 moles times my cp is going to be 5/2 of r times change in t, which is the same as 2 moles times 5/2 times 8.314 joules per mole Kelvin multiplied by a change in temperature. A change in temperature between 2 points ማለት from 600 ሲቀነስ 300 Kelvin ይመጣል። so ይሄ ሲሰራ gives you around 12 gives you around, so this is around 12,471 joules ይሆናል ማለት ነው። so this is my q total. now let us also jump to question number 19. now question number 19 says during an adiabatic expansion, we have an adiabatic expansion, the value of q equals to 0. The temperature of the number of moles is 0.1 mole. The gas is oxygen. now oxygen which is diatomic gas drops. so it drops from a temperature initial of 30 degrees Celsius, that's around 300 Kelvin. It drops to around 10, that's the degree final, 10 degrees Celsius, 283 Kelvin. so the question is, how much work does the gas do? now to solve this question, since the process is adiabatic, the change in internal energy, which is q plus of the work done on or a q minus of the work done by the gas ነው የሚሆነው አይደለም። now since q equals to 0, change in internal energy equals to negative of the work done by the gas. ይሄ 0 ስለሚሆን so the work done by the gas is negative of change in internal energy. so the change in internal energy of the gas, which is simply እዚህ ጋር ያለው it is diatomic, is equal to 5/2 of nr times change in t. so this is 5/2 of 0.1 moles times 8.314 joules per mole Kelvin multiplied by change in temperature, ሁለቱ መካከል ያለው change in temperature, which is around 20, which gives us a change in internal energy of around minus 41.57 joules. But we know that the work done by the gas is negative of change in internal energy. This is negative of negative 41.57 joules, which is 41.57 joules ይሆናል ማለት ነው። at b ላይ ደግሞ what is the heat ነው የሚለው, the heat is going to be 0 since the process is adiabatic. question number 18. a certain ideal gas has gamma which is around 1.33 ከሆነ calculate CV and CP ነው የሚለው. now remember that gamma is CP over CV, but we know that always that CP is CV plus R ነው. so this is a CV plus R over CV, which is 1 plus R over CV ይመጣል. so from this, which equals to gamma, so from here CV equals to R over gamma minus 1. so R is 8.314 joules per mole Kelvin multiplied by a gamma of 1.33 minus 1, which is 8.314 over 0.314 33, which gives us 25.19 joule per mole Kelvin. So this is what my gamma is. Now, since I have found my gamma, I can find my Cp as well. That is, my Cp is Cv plus R, which my Cv I have found to be 25.19 joules per mole Kelvin plus 8.314 joules per mole Kelvin, which gives me 33.5 joules per mole Kelvin. So my Cv is 25.19 joules per mole Kelvin and Cp of 33.5 joules per mole Kelvin. So it is always true that Cp is greater than Cv. So question number 17, we have 1 mole of ideal monoatomic gas, that's monoatomic, which is simply found initially at a temperature of 300 Kelvin. Now the gas undergoes an isovolumetric process acquiring 500 joules of energy by heat. So it's isovolumetric process. That is, the amount of work is 0 and it has absorbed 500 joules of energy. Now isovolumetric means at constant volume. So the amount of heat that you absorb at constant volume is equal to QV. So this is the QV ጋር and then it undergoes an isobaric process. An isobaric process in which is a constant pressure. During this process, it has lost minus 500 joules. So at constant pressure, megabar heat is QP. So from this, number A is what is the final temperature of the system, and B, what is the work done on the system. Now this gas in Benayo, number 1, at constant volume heat gabalet, and then at isobaric process where constant pressure here gabalet, the temperature that's gonna happen at finally when new temperature must equal እዚህ ጋር ያገኘነው temperature ሙሉ በሙሉ ከዛ በኋላ ሲደመር እዚህ ጋር ያገኘነው temperature ላይ መሆን አለበት። So for this process, በመጀመሪያው በisovolumetric process QV, which is NCV times change in T አለ። So change in temperature, this is for at constant volume ላለው ማለት ነው, is QV over NCV. So QV is given as 500 joules over, we have the number of moles, which is 1 mole, so minimum effect alone, that's 1 mole, times a CV, that's 3 over 2 R. To order like Azora, we have 1000 joules over 3 times R, which is 1000 over 3 into 8.314. This becomes 40 Kelvin. So the change in temperature during the constant volume is 40 Kelvin, so it's positive. Now since it's positive and we know that heat has entered the system, the temperature final at constant volume is greater than the initial at constant volume. So the change in temperature at constant volume, which is temperature final at constant volume minus temperature initial at constant volume. So the temperature final becomes a change in temperature ሲደመር temperature initial ማለት ነው. So here this is 40 Kelvin plus initially it was 300 Kelvin, so becomes 340 Kelvin አገኛለሁ ማለት ነው. This is for the isovolumetric process. Now for the isobaric process, QP is NCP times change in T. Now here I have my value of change in T, here becomes QP over NCP. This is minus 500 joules over the same process with Ramalfo, that's 5 over 3 joules times CPN, which my value of CPN is 5 over 2 of R. This is again minus of 1000 joules over 5R, which is negative 24 Kelvin. This is my change in temperature. This is negative because the system has lost heat. Now this is my, now it is at constant volume line. this is at constant pressure ማለት ነው። and so from this my change in temperature here must equal the temperature final ሲደመር the temperature initial መሆን አለበት አይደለ? so this is my temperature initially የነበረኝ ሲደመር change in T. now initially የነበረኝ is equal to the temperature final በኮንስታንት ቮሊዩም ላይ ነው የነበረኝ plus አሁን ያገኘሁት temperature. now the temperature final at constant volume የነበረኝ was 340 Kelvin ነው። እዚህ change in temperature ደግሞ ያገኘሁት is minus 24 so I minus 24 Kelvin ባደርግ 316 Kelvin ይሆናል ማለት ነው። this is my final temperature. B what is the work done የሚለው so what is the work done on the system የሚለው አይደለ? yes. now the work done on the system during this process for the isovolumetric process the work done doesn't exist, right? So the work done is equal to 0 ነው የሚሆነው. and on the second one we have at a isobaric process ነው የሚለው. now during the same isobaric process